Today's lesson is on prime factorization. The objective of today's lesson will be, I will be able to find the prime numbers of a given number by performing prime factorization. Review vocabulary for this lesson is factor, product, prime number, and composite number. The new vocabulary that you will learn in this lesson is prime factorization. Factors are the numbers you multiply together to get another number. The factors for 12 are in the bubble to the right. 1 times 12 equals 12, 2 times 6 equals 12, and 3 times 4 equals 12. The numbers 1, 2, 3, 4, 6, and 12 are all factors. These are the numbers that we multiplied together to get another number, in this case 12. A product is the answer when two or more numbers are multiplied together. The product that we worked with is 12. Do you remember what a prime number is? A prime number is when the only factors of that number are 1 and the number itself. For example, the numbers 2 and 3. Let's take a look at those. What are the factors for the number 2? 1 times 2 equals 2. Are there any more factors? No. Let's look at the number 3. What are the factors for their product 3? That's right, 1 times 3. Are there any other factors that will equal 3? No, that is correct. So number 2 and the number 3, each of them only has one set of factors. Let's look at the number 4. What are the factors for 4? I always start with the number 1 and the number itself. 1 times 4, that equals 4. Can you think of any others? That's right, 2 times 2. 2 times 2 equals 4. Those are factors for the numbers 2, 3, and 4. A composite number is a number that has more factors than just 1 and itself. For example, let's look at the number 12. Let's look at the factors that we saw earlier for 12. Again, let's start with the number 1 and the number itself. What are the other factors? 2. I like to go in numerical order. That way I make sure and I don't forget anything. 2 times what equals 12? 6. That's right. Is 3 times something equal 12? Yes. 3 times 4 equals 12. Now if we go down to 4, our answer is going to be 4 times 3 equals 12. Since we already listed the number 3 times 4, we don't need to do it again. 12 has 3 different pairs of numbers to equal the product 12. Because it has 3 different pairs of numbers, of factors, is it prime or composite? If you said composite, you are right. A composite number is a number that has more than one pair of factors to equal that number. The factors for 12 are 1 times 12, 2 times 6, and 3 times 4. Since there are more than one combination of factors to get the product 12, it is considered a composite number. Let's look at prime factorization. Let's look at the word first. If we pull the word prime down and take a look at it, remember the word prime, that means the two factors, 1 and the number itself, are the only factors that you can have that one product with. Factorization is figuring out all the different factors that equal that product. When you put the two together, we are looking for the different factors that in the end are only prime numbers. Prime factorization breaks numbers down into prime numbers. For example, if we look at the number 12, we make two tree branches off of the main number. Two numbers multiplied together that equal 12. We're not going to use 1 and 12 because if we do 1 and 12, it's almost like starting over because we still have the 12. In this case, when you do prime factorization, you will not use the number 1 and the number itself. Think of two other numbers. Let's try 2 times 6. When I look at 2 times 6, I know that equals 12. So we're on the right track. Now we get to look at these two numbers. The number 2, I know, is a prime number. I'm going to circle it right away so I don't forget it later on. I know number 2 is prime because the only factors that you can multiply together to equal 2 are 1 times 2. What about 6? Is it prime or composite? If you said composite, you are right. If we come over here and work with 6, we have 1 times 6. We also have 2 times 3. It has two pairs of factors that equal 6. That's what makes it composite. So let's do another tree branch off the number 6, and let's use the factors 2 times 3. Once again, I know that 2 is a prime number because the only numbers that you can multiply together to get 2 are 1 times 2. But what about 3? Is it prime or composite? If you said prime, you are correct. The only numbers or factors multiplied together that equal 3 are 1 and the 3 itself. So I'm going to circle the 3 also. Now you can see that we are done. We don't have any more composite numbers. The numbers we have left are just prime. This is the same sample that we just did, identifying the prime numbers. The next step is multiplying those numbers together or showing them in a number sentence. You take the first prime number, usually you start with the smaller number, and list those until you are done. The next two. So far we have 2 times 2, and we need to add the times 3 to our number sentence. Okay, we've got all those prime numbers. Now the last step is to check your work. 2 times 2 is what? You're correct. That's 4. Now bring down the rest of the problem. Now let's do 4 times 3. I like to make these little carrots and touch the bottom numbers so I know that I have used those numbers, and then I put the answer at the bottom of the carrot. What is 4 times 3? You're right, it's 12. 12 is the number that we started with. This right here, 2 times 2 times 3, is the prime factorization for the number 12. This right here is the answer we want to see. Let's try another number. Let's do 18. I know that 1 times 18 equals 18. I'm just using work over here on the side. Remember, I like to go to the next number. Does 2 times something equal 18? Yes, that's correct. 2 times 9. How about 3? Yes, 3 works. 3 times 6. Does 4 work? No. 5? No. And look, we're back to 6. Once you get back to one of those numbers you've already used, you know you're done. Let's do 2 times 9. So 2 times 9 does equal 18. Now look at your 2 factors. 2, is it prime or composite? Well, by now I know it's prime. We've worked with this number enough to know it's prime. The only numbers multiplied together that equal 2 are 1 times 2, and that's a prime number. Let's look at 9. Does 9 have more than one set of factors? I know it has 1 times 9, but it also has 3 times 3. Since we don't use 1 times 9 in our factoring trees, let's use 3 times 3. Bring down that carrot or those tree branches. 3 times 3. Is 3 a prime number? Yes, it is, because the only factors that equal 3 are 1 times 3. They are both prime. Now you're not done. In order to do prime factorization correctly, we need to rewrite these prime numbers into a problem. 2 times 3 times that last 3. This is our prime factorization. Now, I'm going to switch colors so we can check our answer. What is 2 times 3? That's right, it's 6. Bring down the rest of the problem, the times 3. What is 6 times 3? You're right, that's 18. Is that the number we started with? Yes, it is. So 2 times 3 times 3 is prime factorization. You always want to look at your numbers that you are left with at the end of your problem. If you have a number in this box that you know has more than one set of factors, then you know you did not do the tree branches enough. For example, let's take a look at one of those numbers. Let's look at the number 28. Think of some factors that equal 28. How about 7 times 4? Now let's look at 7. We have to decide, is it prime or composite? To decide that, we look at the factors. I know that 1 times 7 equals 7. Does anything else equal 7? No. So it is a prime number. We circle our prime numbers. Well, let's pretend that I'm not really thinking very clearly about the 4, and I think 1 times 4 is the only combination of factors to equal 4. So I'm going to circle that. Or I just get sloppy and forget. So let's pretend this is my final answer. Then I go back and say, uh-oh, I remembered 2 times 2 equals 4. And so does 1 times 4. 4 is a composite number. It cannot be in my prime factorization box, my final answer. So I realize that I did not do that last step correctly. I need to go back up and look at my 4. I now remember that 2 times 2 equals 4. Now is 2 prime? Yes, it is. If this one's prime, this one has to be prime also. Now we're going to rewrite our numbers into a prime factorization math sentence. Remember, we start with the smaller number. 2 times 2 times 7. Now let's go back and check our answers. What is 2 times 2? That's right, it's 4. Bring down the rest of the problem. Times 7. And 4 times 7 is 28. That is our final number, and that also matches the number we started with. In today's lesson, you were able to find the prime numbers of a given number by doing prime factorization, or sometimes we'll call it factoring trees. Tomorrow, you will be able to practice this brand new skill in class.